For my part of the project, I did the square cross-section, and to find the theoretical volume for the square cross-section, that is the integral of the area of a square, which is just the function squared. The function we used is 1/4 x squared plus 1. As you can see from our work here, we solved the integral, getting x to the 5th over 80 plus x to the 3rd over 6 plus x. Then we plugged in the numbers 4 and 0 to solve. After plugging them in, we found that equaled 412 over 15, or approximately 27.467. This is our theoretical volume using the integral. As you can see from this chart, we show the x value, what you get the y value when you plug in the x values, the area, which we did y equals the function squared, and then the volume, which is just the integral of the area. And as you can see, our total is 27.466. To find the approximated value, we did the function, and we used a left-hand Riemann sum. So as you can see from our x, we still did it in half intervals, so 0.5, 1, 1.5. And we plugged in the area of our function, and we multiplied it by delta x, which is 0.5. We took the area of the face, and by multiplying by the change in x, we found these values for each of the tables, and we added them together to get our value of 21.6568. The approximate value is lower than the theoretical value by about 6, and as you can see from Haley and Reese's parts, this is a normal occurrence. The largest cross-section we had was the square, with it being 27.4667, and the smallest was the isosceles triangle at 6.8667. After completing this project, Haley, Reese, and I have now learned the differences between the cross-sections even more fully, and we have a better understanding of this subject.